All right, should we go ahead and get started?
Sounds good.
Okay. Hi, everyone. Thanks for joining us, and welcome to today's webinar, Eliminating Dependencies in Testing, How Virtualization Makes Unavailability a Thing of the Past. My name's Amy Huey, and I'm on the marketing team. Today, I'm joined by Nathan Wright, Technical Product Manager. How's it going, Nathan?
It's going very well.
Great. So I just wanted to go over a quick few housekeeping items before we begin. The first is that this session is being recorded, and you will receive a recording within the next couple days. If you have any questions, please ask them in the Q&A box. The chat will not be monitored. And we'll try to answer some questions as we go, but we'll primarily be doing Q&A at the end. And then finally, we do have a couple poll questions for you guys today. These really just help us provide you guys with more relevant content in the future. So we'd really appreciate if you could help us out by answering these questions. And so with that, I will pass it off to Nathan and we'll go ahead and get started today.
Perfect. Thanks again, Amy. Once again, my name is Nathan Wright. I'm the Technical Product Manager here at SmartBear, working mainly with our API tools, both testing and virtualization, as well as a little bit with our design, API design solution, Swagger Hub, which we'll kind of touch on a little as well today. Just as a kind of a high-level agenda of what we're going to go through, we'll introduce SmartBear. I'm sure some folks are familiar with us here, but I do like to just kind of make sure everyone understands or gets a good look at a kind of full product set. Just a few minutes there. We're going to look at some different slides around this concept of eliminating dependencies. We're going to frame this with testing, but I think we can really say eliminating dependencies across the whole SDLC. So not just in testing, but also in development, as well as kind of infrastructure deployment and that kind of thing. When we look at all of the different ways that services are being created now and the size of the components of these like larger applications, things getting broken down into smaller pieces, it means that there's a lot of dependencies regardless of what stage that we're in. So we really want to talk a little bit today about eliminating dependencies. So after we go through a few slides, we'll jump into a demo. We'll, at a high level, talk about kind of a situation where we might have a dependent service. Maybe we have an upcoming change to that service. We can expect some downtime to happen. So we want to virtualize it and allow us to not only build tests, but also facilitate and support, like a front-end development group who might be utilizing that service for an updated version of their application. So that's the plan. We should have plenty of time here to get through the session today. As Amy mentioned, any questions, feel free to post them in the chat. We'll kind of keep an eye on that as we go along, and then we'll collect them up at the end as well and see if there's any questions that we want to answer there.
Yeah, sorry, if you could put them in the Q&A box, that helps us track which ones we've answered and haven't. So the chat won't be bothered.
Okay, never mind. Don't put them in the chat, put them in Q&A. Cool. So yeah, just as an introduction here, talk a little bit about SmartBear. We've been around for the better part of a decade, or a decade now. It's been quite a 10-year span for SmartBear. We now have 11 global offices, which is pretty remarkable. I'm today actually working from the Florida office that we have. Some great teams down here and a lot of good work happening. But I am typically based out of our headquarters up in Somerville, so it's been great to travel and see, SmartBear and some of the other offices. I've also had the opportunity to go to our office in Europe and see some of the work that gets done there. So I really like that SmartBear has this global presence and is this really nice kind of mixture of cultures and personalities across all of these different offices. Speaking of global footprints, when we look at our user numbers, our customer numbers, it really is remarkable how kind of wide the kind of groupings are who look at SmartBear and come and join us and use our tooling. I love that number, the 22,000 plus customers. That's something that's always growing. We have a lot of great applications and tools that people see real value in, And SmartBear is accompanied by acquisition as well. So we're always adding new products to our portfolio, making sure they kind of fit in with the existing tool set. And then we build on integrations and connection points and tell this much larger story. The really impressive number for me, though, is that 6.5 million users. And so that's not only our customers, but also the users of our free and open source tools. Some of you might be familiar with SOAP UI open source or something like the Swagger set of tools. These are all open source and made kind of publicly available. We see a lot of groups have real success with these open source tools and really, enjoy using the functionality. And then when we show some of the capabilities of the professional tool set, everyone gets really excited and kind of sees the growth into those professional toolings. Final note, 525 plus employees. I'm sure that's even higher than when I made this slide a few weeks ago. We are actively growing. So if you are interested in joining us here at SmartBear, definitely reach out. Just a little bit of recognition here. We are well regarded by the analysts in the industry. Gartner ranked us as a leader in their software test automation MQ last year, and a big part of that was actually the support that we do have for eliminating dependencies as part of that testing process. So looking forward to kind of digging into that piece a little bit more once we get into it. And then some quotes on the right-hand side. Again, it's not just software test automation. We do well with our API lifecycle kind of reviews and some of the other analyst checks that go on throughout the year. So this is what I really wanted to get to, just a high-level look at the SmartBear portfolio. On the left-hand side, we have our kind of early-stage tools, something like Swagger Hub for designing, defining API definitions using OAS. We then integrate that into a number of different tools and platforms. We can consume those definitions and not just Swagger and OpenAPI, but other definitions and other strategies as well in our testing stack. So when we look at something like SOAP UI Pro for functional testing, Load UI for performance, and then our main kind of focus for today, which is ServiceV, which allows us to virtualize APIs. And there's a lot of different paths for getting started. We do have a limited amount of time today, so we're really only going to focus on one. But we're only going to be able to scratch the surface of what is a really complex and deep tool. And we see a lot of people do some really interesting things with it. I should note we do have UI testing tools as well as BDD kind of scripting and creation tools. That's kind of on the top half of the graph here. So yeah, I focus mostly on the API side of things, but we absolutely support UI testing and development as well. All right, so Amy, did you want to ask this poll?
Yep. We have a poll for you guys. Do you have any gaps in your software testing tools just before we get into the presentation?
So this is really interesting for us to understand. I think it helps frame the conversation that we're having. If we have a lot of UI folks on the call, that's one thing. If we have a lot of API teams, then that's another. But it helps us kind of understand and recognize what's going on in the industry and where we can start to improve our tool set to really, enhance and make everybody's lives a little bit better. All right, so let's go ahead, and I think it's now time to actually dive into some of the kind of conversational piece of what we'll be talking about today. Now, I like to kind of prepare, or I wanted to kind of lay out a few slides here based off of what we talked about last year during our State of API survey. So we surveyed thousands of developers from around the world, got a ton of information back from everybody, and saw some really interesting trends. And I think it helps us to highlight some of these trends when it kind of brings us into the conversation around virtualization. There's things happening in the industry. There's things happening with the way that organizations and teams are building their APIs and applications that really creates this kind of need for something like a virtual environment. We are just naturally creating all of these dependencies. A lot of people will consider it to be a very beneficial or very good thing, isolating concerns and creating these smaller services that have kind of streamlined roles. But it, of course, exposes this complexity and this mixed environment kind of development strategy. And all of that was kind of reinforced when we did from the survey. So Just a note here, it wasn't just developers, it wasn't just testers. We actually had a lot of people get back to us from like the development, or sorry, from the design and architecture space, as well as some of the other more kind of automation DevOps type personalities. So I do think it is a really good mix of responses here. So the first thing that I like to talk about, and I'm partially biased, having worked with Swagger Hub for a number of years, is we're really seeing Open API start to become the standard for defining services, and I think this is important. We're not really going to drive home too much Open API today. It's going to be the foundation of what we do, but seeing the growth in this definition for RESTful APIs, I think, comes from the way that teams are kind of building and sharing information about the services that are quickly changing. But it also gives us this like artifact that we can start to use as the foundation of something like a test suite, or the foundation of something like a virtual service. If we, take our time to design out, the changes and the implementation of a new service, before we pass it on to development, not only can we do interesting things like generate SDKs and generate clients for other development work, but because it does define all of the requests and potential responses and essentially the structure of how we access those through the API, we can generate these test cases, we can generate virtual services very, very easily, and bring in some of that dependency management from that definition layer. So I think it's really interesting, and again, not just the strategy and the workflow around it, but actually seeing the growth and kind of the need reflected in the industry for something like a definition standard for RESTful APIs is really interesting. And then we look at new kind of implementations or new types of APIs, something like GraphQL, that have the same kind of definition or schema really kind of at its core. It's really interesting to see the way that these are evolving to kind of reflect the needs of other groups. And I think it is a lot of dependent or consumer-driven requirements. On that same note, and I've mentioned it a few times, it's probably no surprise here that microservices have changed in a big way the kind of structure and the complexity of organizations. Now, it was really interesting to see that this wasn't just large organizations, but new startups, smaller as well, who got back to us in the survey. There's this kind of adoption of this microservice development, and it's really seen a ton of growth since we ran the survey in 2016. That year, we only had 20% of people saying microservices have or will have an impact on the way that we do things in the technology space, and now it's just about 3/4. So really seeing the pendulum swing, and I think people are seeing the kind of road in front of us when it comes to these microservices. And again, when we start to look at the different ways that we can deploy these in these mixed, hybrid environments where we have cloud and on-premise kind of combinations of stacks, having these microservices running in all these different locations, creating these connections between them, it introduces a lot of complexity, but obviously there's a ton of benefit in that as well. Another note on kind of the microservice conversation here. When we talk about APIs, when we talk about services, we as a company at SmartBear generally frame them in this like external or consumer-driven space. It's a revenue source for a company. It's Bank of America exposing an API, so they can integrate out to payment platforms, that type of thing. But when we looked at the survey and when we really think about the way that these things are being built, for every external service, there's X number of internal ones that have to support that. So creating these internal and external APIs, internally focused ones, purely internal focused, and then seeing what kind of strategies needs to be overcome in order to support that kind of complex ecosystem. So being able to kind of create a much neater integration between internal teams and tools, exposing data in new and interesting ways for it to be adopted or consumed by internal teams, partnering with external organizations. That one is one that we really like to talk about, the idea that we can have a third party or some external resource integrate with our tooling through an API, and really we can start to build applications and make interesting things together. So again, this concept of microservices, this concept of breaking down these monolithic services, I think is really important. But again, it's just introducing more dependencies, more breakpoints, more kind of touches between these two services, especially when we think about this happening at scale. I talk to a lot of teams who work in their own kind of world and build their own services and maybe work very closely with a parallel team, but their services are actually being consumed and available across the organization. So they might not necessarily know who is a dependency or who they are a dependency of, if that makes sense. So yeah, something really interesting that, again, I think is changing the way that organizations are building and deploying software. So just as a level set, monolith to microservices is a concept or conversation that's been going on for quite a few years now. Um, when we look at these monolithic services, they are kind of clunky. They don't mesh necessarily well with these agile development strategies. So being able to break these down increases our efficiency. We can essentially say, okay, instead of having all of our teams kind of, be on the same sprint cycle and kind of be, pushing code and changes at the same time and having all of these kind of moving parts coming together in like one big bucket. Instead, we're able to kind of segment that out and create the separation of concerns and say, okay, we have these teams who are working at a very high efficiency or working in a very efficient way, and we don't want to be prescriptive about how they're actually doing that. Maybe one team is operating on these 2-week sprints, maybe another team is doing continuous deployment and updating every day and that type of thing. So yeah, really, really allows us to kind of break things up and facilitate and support um, a lot of different development strategies. There are some issues that come with this. We're always going to be supporting some legacy components. I couldn't tell you the number of times that I've heard about a machine tucked away in the closet somewhere that actually is integral to the entire application stack. And if we turn off the lights in one side of the building, it turns that off, and it's a total nightmare. So having these legacy components is something that I think is going to be kind of an issue indefinitely at this point. Maintaining discoverability, this is kind of what I mentioned before, where we might have these internal teams who are developing kind of segmented out from one another, but being able to discover and see and recognize services and not have to recreate what might be already done, I think is really important. With that comes this idea that we're enforcing standards. If I'm submitting making a post request with a user object against one service, I should be able to reuse that same user object for another and another and another. We should be, as an internal group or as an organization, have these standards that we all follow. And it can be really hard to actually maintain and support those as all of these teams and kind of groups are running at their own speed. And it just underscores the importance of good testing, of good coverage, of doing things like a design first strategy to building APIs. I think this is really important. The last one there, again, I think I mentioned it now on every slide, this idea that as we break these things up, we're increasing the number of dependencies, we're increasing the number of points of failure. There's a lot of kind of moving parts here, again, that we have to maintain and support and ensure that are kind of working well together and available. It also introduces this idea of a service-driven company. I think that this is something that we're going to see some huge growth in the next few years. Let's say that we broke apart a monolithic service. We were building microservices, and we have a new requirement to send an instant message to our entire organization. We're not going to build our own client for messaging and have everybody install it and just have a kind of an integration. We're more likely going to use something like Slack that already exists, and we can just integrate out into. That's true across a number of different platforms, messaging services like Twilio. Payment processing is a huge one. I couldn't tell you when I searched for these services, the number of them that seem to support payment processing and moving money around from point A to point B. Something like Salesforce as well. It's a huge industry and a huge market for essentially doing one thing very well and integrating that into other teams' work and other teams' platforms. Now, virtualization is a really neat way to kind of tie things together here. When we look at these external sources, these external companies, they may or may not offer a sandbox environment. They may or may not have that sandbox environment be stable or have it be localized to my work. Virtualization essentially enables us to create our own sandbox and make it specific to our own needs. So as we're building out new integrations, as we're building out new tests, we can reduce the cost of actually using these services. Essentially, we only need to lean on them in kind of later stage environments. We can also create fallback options when something goes wrong. We do have a an integration point out to one of these payment processing, and something happens and it's non-responsive, instead of XPath happening, then we can start to navigate tools and integrations down an end path and change potentially the way that that's handled. So yeah, it's really interesting to see virtualization kind of mimic this. We have some really neat functionality for essentially scraping or recording interactions with something like a service-driven company, and then bringing it down again into our local environment. The one that's not on here that I think is really interesting is the idea that we can control state with a virtual environment. Because we have created it, we own it. We're going to be able to essentially force it into a certain state if we need it to. So maybe there's a certain point where we actually need something like Twilio to become non-responsive in order to make sure our client applications are working correctly. So having that virtual asset that we can essentially flip a switch and say, okay, it's gone from kind of a happy path to now sending back 500 every nth call. That's the kind of thing that we can actually force to happen with a virtual asset. That is really hard to kind of mimic or ask Twilio to do. That's the last thing that they're wanting to do, is create these, bespoke sandboxes just for our testing needs. But absolutely something that we can do internally. Cool. So when it comes to microservices, multi-layered services, I don't think that we need to get too far into this, but there's this idea that we might be working with a UI, which is kind of the demo app that we'll be talking about today. And it's dependent on a service underneath it, or a couple services. And those services, again, are kind of dependent on another series and another series and another series. So there's this like stack of applications that are all kind of communicating, passing data back and forth. Now, in many cases, these are separated by different teams, managed by different groups. And if we have an issue in the front end, it can be really hard to trace back exactly where in this application stack we're actually having the problem. So there's a couple of ways that we can use virtualization to work back from that. We could start to virtualize at a very high layer. If we know that generally the application stack is stable, we know that there's upcoming changes happening, and we just need to know, like, at the topmost layer what those changes look like for, in this case, my my front end app. Then we can start to mimic that top layer out and start to interact with it. And really, as all of the changes might be happening under the initial layer there, we can kind of be prepared and ready for those changes when they are deployed and when we do remove that virtual service. We can also do the inverse, and maybe we have all of these dependencies kind of from the top all the way, or we have a dependent service that's used from the top all the way down. And that's something that we might need to virtualize. This is a very common kind of place where we have like a legacy system that we might be working to replace, and we need to introduce like a virtual asset that mimics the functionality of that legacy system while we do some work. There's a lot of different reasons that we want to either do A or B, the top layer or bottom layer. But I think really the sweet spot is when we try and find those layers that are integral to both of those, and we can start to virtualize an entire kind of set of dependencies or a set of applications or APIs, and really start to expose those and use them across both the back end, the front end, across all these different testing teams, development groups. Again, supporting like these really complicated environments and trying to chunk them out in such a way that we can start to, again, virtualize them and take advantage of what that virtualization brings. Now, when I talk directly with customers, probably the most common question I get when we do discuss virtualization is, well, we already do mocking, so what's the difference? I'm not really getting why mocking or virtualization, why one is better than the other. It's a fair question, right? Essentially they at a high level mean something very similar. But for our context or for our frame of reference today, we are going to kind of show a little bit of a difference between the two. So mocking is, in our world, pretty static. It might share kind of a set of core answers that it could return when it's asked a question, but there's no depth to them. So a mock might be able to say, okay, this service is asking for the weather versus asking for, in this case, like movie times or something like that. But it's not really going to know the context of that. It's not going to know a specific movie that we have to return data for or a specific date that we want to return the weather off. It's really just going to mock that kind of top layer of what an API is going to do. Virtualization is actually going to introduce that context. So we can actually say, okay, so we not only want to return potentially an answer for when a service asks for the weather, but we can actually contextualize it and say, okay, there's a query parameter in there that has the date. When the date equals this range, then send back this, this weather. And if it's outside of that, send back something else. And when we start to introduce this logic and this kind of contextual component, it makes the API feel a lot more real. And we can take that a step further and start to introduce like kind of behavior to that as well. So our tooling has a really nice piece of functionality where we can introduce latency and mock like a thread limit against a service. And it will actually behave much more in line with a real API, as opposed to just a mock, which is kind of just going to ping back a response to whatever query is being asked of it. Cool. So we're going to dive into the demo here, and we'll work through this in a couple of different ways. We will talk a little bit about kind of the front end or development and supporting dependencies on that side. But then we'll also take a look at how we can start to utilize virtualization for testing as well. All of the work that we'll really be doing today is going to happen in ServiceV Pro. So this is our virtualization environment. It allows us to generate from a specification like we will today, or we can record live transactions and convert them into a virtual asset. This is a really neat piece of functionality that I think is pretty unique to ServiceV. As I mentioned before, we can also configure network server-side performance. We can emulate the behavior of an actual API. If it takes, 100,000 milliseconds to respond every time we make a call, well, we actually want that to be reflected in our virtual space. We can also share these, so we'll talk a lot about creating and kind of using these locally in this demo, but we can absolutely do this work and create them and then share them out into essentially a public or a private cloud through something that we call Virt Server, which is going to actually take that Virt from my local machine, place it up into a shared environment, and then allow anybody really to start to interact with it. Great. So for our work today, we're going to talk a little bit about that plan phase. Okay, so we have an initial plan that's going to be happening, and we have an idea of what is going to change in this case on the API side. Instead of us just saying, okay, that sounds great, and we'll wait in 2 weeks when you've made those changes, let us know, and we'll start building our tests. We'll start iterating on the user interface for this. We can actually stand up this virtual asset, and we can take that virtual environment and use it not just for like our UI development, but also for our test development for the APIs. So as things come together at that later stage, as we bring together all these different components, as the API is being rolled out and staged, our tests are ready, our front end is ready, the API should meet the spec, and we should be able to deploy things in a much smoother fashion. Great, so I'll just jump back here. What I'm going to do, first things first, we'll just take a look at the service that we're going to be interacting with today. Some of you might have seen this before in another presentation, but we have this incredibly complex calculator that we've kind of created here. And essentially what this is doing, it's taking two values, and then we have a couple of actions that we can perform against the service. Just input two numbers here, add them together, or subtract them from one another. And maybe this is a microservice that we're using internally just to, I don't know, streamline the addition or subtraction of two numbers as part of our larger application stack. Now, it works okay, but it's pretty limited in its functionality. We can't multiply, we can't divide. There's not really much else we can do with this. When we look at the API, we see essentially what we see in the UI, but through the back end. So we've got these two calls. We've got this post call, allows us to input two numbers and then get back a response with that value that we're seeing rendered, and then see the subtraction option as well. And again, this is let's call it version 1 of the service, and we've now got this plan. Let's imagine that we gave some feedback, or we've had some feedback. We really need that multiply. We really need that divide. We're not able to scale this thing up, and we're doing all kinds of weird things with the service and adding essentially like a series of calls to mimic multiplication or something. So we've given our feedback, and now we have insight into what's happening with version 2. So I'm just going to pull up that version. And this is going to be in our Swagger Hub tool. Again, we're going to use OpenAPI. I think hopefully I kind of presented the value underneath this design first and the direction that things are going. But we could absolutely do this manually as well. If we'd had a meeting and we said, okay, we're going to add multiply, we're going to add divide. then we can go back and start to implement that on our own. So here we have version 2, and there's a couple of new things in here. We've got multiply, we've got divide, we've got this new status, so we can query and see if the service is running. And this is now what we can treat as a plan, right? It's essentially a contract that the API team is going to ingest and say, all right, we know exactly what is required of us. We know the methods, we know the paths that are going to be exposed, we know the input parameters, and we also know what we could potentially respond with and the values those responses contain. So from a testing perspective, we now, we know that the API team is going to be implementing this. We want to do on our side kind of the testing work. We want to build out our test suites, our test cases. We want to make sure we've got coverage so that either when the application or the API is updated, we have those tests ready to go. Or even if we're following something like a test-driven development strategy where we need tests before we start actually making changes and updating code, then we could start to build those out as well. So there's a bunch of different reasons that we'd want to do this. But let's go ahead and just grab this definition from the back end of the tool. And we're going to jump right in here and just create a new empty project. So the first thing that I want to do is import that definition into this platform, Ready API. Ready API is not only going to be where we do our virtualization, but it's also going to be where we build out our functional tests. We could do performance tests within here. There's a whole set of functionality that we won't even kind of touch on today that I think is really powerful. So let's just go ahead and import that Swagger definition or OpenAPI spec. There we go, make sure we've got the right version. And what the tool has done, it's essentially brought in all of those different calls that we just defined. And so we know that we could reach out and touch the actual service with add and subtract. We could make real calls and get actual data back. But it's these multiply and divide ones now that we could potentially create these test cases for, but we're really not going to have any data to play with. We have nothing to assert against because there's no responses yet. This is where we need to start to think about virtualizing these assets. To do this, let's go ahead and right-click and generate a virtual service. Again, this is just importing that definition, and then just through a couple clicks, we're now going to be able to move this over into ServiceV. And what this is going to do, it's going to take that contract, all the requests, all the responses, and it's going to structure it in a way that we can say, okay, this is the values that we're listening for. Essentially, these are the requests that we're listening for. And here's the potential responses on the right-hand side that we could return. Now, when we take a look at these, because we were using that definition, we should have some example data within here. So all of these responses, obviously in this case, very simple. But this could be something much more complex, and it will be pre-populated with example values and all the information that we potentially need. So let's go ahead and take a look at this one. So we know that we already have coverage maybe for add and subtract, so I'm not going to concern myself too much with those. It's really this multiply and divide one that I want to touch on today. First thing I want to point out is that we have just a fixed value here. So if we started using this in our test environment, we could essentially say, does the result equal 16? And we would get a passing test. But as we know, that's not the way that the actual service is going to work. We're going to be inputting numbers. We're going to be getting variable responses back. So I want to create something here that's a little more dynamic than just this fixed value. To do that, we're going to introduce one of the first pieces of ServiceV, which is the concept of data sources. Data sources we can open up right here. And in this case, we know we want to generate a random number. We could, if we had like a data set that we wanted to link this to, or we had a database that included all of our, test data or something like that, then we could link that up. For us, we're just going to generate a random number. And let's just call this multiply value. I think we were in multiply. And here we can see we've got some different options. We're going to grab integer, and let's make this a value between 10,000 and 1,000. There we go. So now, not only are we going to have a slightly larger number, but every time we make a call out to this, we can expect it to come back with a new value. And in this way, when we build our tests, we're going to have to be much more mindful of what we're actually validating. It can't just be right-click, double-check that the response equals this response, because there are going to be elements of that are changing. Some of them might be static. The key here is always going to be the same, but it's the value that we need to understand is going to be dynamic. Great, so the last thing that we need to do there is just create a reference to that random number that we generated. To that, we can delete the fixed value, scroll down, and we've got this little menu for connecting to data sources. And just throw a right click here, you can say get data by value. And now this is a reference that will get resolved, and let's actually see this thing in action. Let's go ahead and run this. We're listening at localhost 8088 here. And if we jump back now, and let's say update this to that new endpoint, we should expect to get these random numbers back. So 3215 there, 4327, 4311. So this is changing, and again, we could create this larger set of numbers. Maybe we even have an edge case in here where we have like an exclamation point or something that came back accidentally. We could actually start to pipe that data in and build catches and tests for it. Now, some of you may have noticed that we're not really introducing any logic here. Essentially, every time we run a request, it's flipping between the 404 and the 200 response that we have to find. And it's also not really checking if these input values are introduced. So the service, the virtual service right now is mimicking some of the data that's coming back. It's not actually mimicking the behavior, as I mentioned that it should. We can, in just a few ways, actually introduce that in ServiceV. The first one we'll do, let's go ahead and check to make sure input 1 and input 2 are being included. To do that, we're going to change this from a sequence, which is what was closing this, just to flip between these two, down to this parameter option. And here within parameter, we can say if our crew parameter 1 is, let's say, maybe less than 20, and crew parameter 2 is less than 30. We'll send back response 1, which was our 200. Just double check that. Yep. And then we can set a default response here. That'll be our 404. So anything that comes in that doesn't meet those rules that we just defined, let's go ahead and send back a bad request call. And now when we actually send these requests, we're going to be able to not just flip between those two, but we can see that as we start to go outside of those rules that we just defined, we're actually creating this behavior. We're mimicking the way the actual service might work. We could even say, you know, if we get number 1 but not number 2, the virtual service returns a message that says, please include, you know, 2 query parameter values or something like that. So just a few clicks here, right? I think we've been in the tool for about 5 minutes. We've already got this pretty dynamic service. We're generating these random values. We've introduced some logic here. And this is going to work pretty well for me to now just go ahead, create a new test case, and within SOAP UI, we actually have a number of ways that we can build out some validations. So through, for example, just a right click here, we can check for not just the content. Remember, this is going to be dynamic. So if we did do this validation, it would keep failing. But we can actually do this for the existence. So let's just make sure that's true. And again, now we've created this little assertion down at the bottom. So this is pretty neat. Now we could go ahead and do essentially the same thing with the divide option and have both of these available to us and start to interact with them. Now it does introduce an interesting question where let's imagine that we virtualize multiply and divide, but we've also got test cases that cover add and subtract. If we run those right now against the virtual environment, we're going to get some really mixed responses because we have actually not touched that add and subtract, but the test cases are going to be set up for the actual service. So how do we kind of layer this combination of old and new functionality together? That's something that we have some workflows for right within ServiceV. One of the nice things that we can do with this is do what we call route and record or route requests. So maybe we want to route non-virtualized requests. What that's going to do, it's going to take anything that isn't defined in this list and essentially forward it on to the actual service. This means that I could remove both of these add and subtract calls. Let's just delete those. And so now we only have virtual kind of setup for the new information, for the new data that we're going to be interacting with. And these aren't going to route on, but we do have to just update this. Here we go. For this extra location. There we go. And we can start this up again. And now if we jump back, we should expect this to still make the same calls. But if we open up now add, and again, we change over, actually, let's just add a new environment here. It saves us switching around a bunch of times. Oh, so we can see that the endpoint is running against the vert. The wrong thing. So the path there is not correct. There we go. So now we're still running this against that localhost 8088, but the tool is actually picking up this request that's coming in. It's recognizing that it's not part of this list, right? It's not multiply, it's not divide. It's forwarding it on to the actual service, and then as the response comes back, it's routing that back again through the vert. So I'm going to be able to build all of my tests, run all of my tests against the same virtual asset, but be able to use this combination of not only virtual data or kind of mock data or mimic data, but also use that real and actual service as well. So again, this introduces some really interesting workflows that I think can really accelerate a lot of test development, as well as allow something like a front-end developer to essentially come in here and start to build out new functionality against that virtual service. I have a couple of minutes, so why don't we go ahead and take a look at what that looks like. Again, this is now not dependencies necessarily for testing, but for actual kind of front-end development work as well. So here we have this calculator. This front end is running locally, but it is interacting with the actual service. Let's go ahead and just grab the URL for that virtual service here. Host 8088. I already know we're going to have an issue because it's going to be looking for this larger path. So let's just see if we can clean that up. So this is pretty bad practice to be kind of going against the definition, but in my case, the definition is just a little bit different than what the application is designed to run against. And then here we go. Let's just go ahead, change this to now interact with this localhost 8088. So in my case, I just have this small config file that changes the endpoint that my calls go out to. And now if we jump back into this and refresh, fingers crossed, we're still getting this data together. But we should be able to now build some brand new functionality. Let's just call this that multiply button. Save. And all things well. For some reason, it's not responding. I imagine we are getting those responses coming in. It's most likely something to do with the way that I've configured this here. So some work to do, right? But it introduces this idea that it could not just be our testing, but we could use that virtual asset once it's been created for a whole bunch of different things. We could have other integration tests running. We could have our CI/CD workflow kind of being built out and run against this virtual asset. So there's a lot of different ways that we can take something that might be created for a test environment and actually share that out and use it across a much larger audience. So I know I've been talking now for about 45 minutes, which I'm sure everyone could use a little bit of a break. Amy, was there another poll question that you wanted to run here, or any questions or anything like that that you wanted to dig into?
Yeah, so I will launch this poll. If you guys could answer that, that would really help us moving forward. And then in terms of Q&A, also, if you do have any questions, please feel free to put them in the Q&A. But Nathan, it looks like you covered so much. Nobody has a single question yet.
Either that or everybody is so confused that they don't want to ask any questions. Either way, that's okay. So yeah, I think if you are interested in learning more, I really like when we can get on the phone with potential users or anyone who's watching and really listen to the use case and kind of understand it and then map some of these high-level concepts that we just talked about back against that. I think it really helps underscore the value of something like virtualization And it tells a really compelling story. When we start to imagine some of these like features and some of this functionality in our own environments, I think it becomes really powerful.
Okay, we do have a question that just came in. Do we have sample virtual service that we can use as a practice?
Yep. So we don't necessarily have a sample virtual service deployed anywhere. I will say that any app in Swagger Hub that you interact with is actually backed by default by a virtual service. So if you have a definition, you could just upload it to Swagger Hub, and it would essentially give you a vert. A lot of the ones that are available publicly there are driven by virtual services as well. So, if I have an API exposed to potential consumers, um, then then they could kind of interact with a mock or a vert, as opposed to it actually being against a real service that we have to authenticate against and you know have a much tighter integration with.
Great. And then I think we have another question, kind of like what you were talking about earlier about mocking versus virtualization. So
Mm-hmm.
how this different, I guess what we just saw, than using SOAP UI to create mock services that simulate API layers.
Yeah, so I think this is worth digging into a little bit more. And I'd mentioned to Amy before that I think it's nice when we write up like a quick blog post for some of these questions. Um, but when we talk about the data source component, so having this variable data or connecting a vert to like a data set, something like an Excel sheet or a database, to my knowledge, that's not something that you can do in the open source SOAP UI, or you would have to do with a decent amount of scripting. I think in about 15 minutes, we were able to create something pretty complicated um, that would have taken a good amount more work, kind of on the open source side. I'll also have to look some of the routing options that we have set up and some of the dispatch styles that we include within the professional version of the tool. I believe are not included in the open source. But again, I think that's something that might be best answered through like a blog post that we can have some documentation links in and all that kind of stuff.
Sure. And I do want to be conscious of time because, as Nathan mentioned, he's currently in our Florida office and he actually has to hop on a flight to come back to Boston. So if we didn't get to your question, we will try to address them in a blog post, or I will reach out with the answers. So thanks everyone for joining us today. We will be sending out a recording within the next couple days of this session. So please look out for that. And I want to thank everyone for joining us, and as well as a huge thank you to Nathan for being here and sharing all of this with us.
Oh, it was a pleasure, and look forward to answering more questions and hopefully doing more of these presentations in the future.
Okay.
Great.
From us. Thanks, guys.
Thanks, Amy.